Hi, just a prequel to this video. I have actually finished recording it now, but just a warning, if you want to use this video as a step-by-step guide to changing your heat break for the Bondtech, please watch the entire video first. Don't just go step by step as I explain through the video. I do make some mistakes. Obviously those are corrected mistakes, but you'll see how I got on, how I corrected things, and so it's important that you follow the whole video, watch it through all the way first. Then if you want to do it step by step, that's fine, but at least you'll know that the points where I've actually not got it quite right. But it wouldn't have been one of my videos if it wasn't a little bit of trial and error here. Nobody's perfect. Anyway, enjoy. Hi, welcome to another video. And today I'm going to talk about the Prusa Mini and changing the heat break for a Bondtech heat break. Now my Mini's been working pretty well, but recently I've had a clicking from the extruder. I've got a Bondtech extruder that's been working pretty well up until now, so I think I'm actually getting clogs on the hot end itself. Now I've put off changing the heat break. I bought this about a year ago from Bondtech, not got around to it, but recently I've been printing some models such as these sort of things. Printing was going well, but then all of a sudden get the clicking noise on some of the parts recently. I've had to raise the temperature of the hot end to try and compensate, which helped a bit, but then I get stringing, a lot of stringing. So today I've decided I'm going to take the plunge and I'm going to have a go at changing the heat break. So what do you need? Heat break from Bondtech, which I believe now comes with the thermal paste as well, which didn't when I bought it, but I think it does now. So thermal paste, Bondtech heat break. I'm going to change the nozzle while I'm at it because the nozzle has to come off, so I've got a spare nozzle as well. You don't have to necessarily do that. To take the nozzle off you need a 7mm socket, and when you're putting it back on you need some sort of torque wrench. This is a Slice Engineering torque wrench. It's designed for 1.5 Newton meters. I believe Prusa says around about 2, so whether it will do it up tightly enough or not we'll find out. It's got a 3/8 end on this socket as well, and that fits in just fine into that. And I'm not sponsored by them, it's just that it was difficult to find a decent torque wrench anywhere around about the 2 Newton meter setting. So I've got that, and a 16mm spanner to hold the hot end while it's being undone. Allen key to undo the bolts on the side, and we'll go into that in a moment. Hopefully that should be about it. So let's get started. So the first thing that I've actually done already is I've heated up the hot end and just to a normal sort of PLA temperature, so 200 210, and then I've undone these 3 bolts. Now if you've not played around with the hot end before, you'll still have the original grub screws. I recommend that if you ever have to undo the grub screws, replace them with bolts. So these are the sort of Allen key head bolts that you get with a Prusa kit anyway, so they're 3mm. So I definitely recommend changing them because the grub screws will very easily strip once they've been tightened and undone a couple of times. So these have been loosened. Next I have loosened the top mount for the Bowden tube, so that I've already done, so we'll move that out of the way. Next, I have started with the spanner that you get with the Prusa Mini. I've undone the top joint here, and you'll notice when you put it back, the coarse thread goes into the body of the plastic and the fine thread goes onto the other brass joint. So we'll put that to one side, and there you've got the PTFE tube there that we should be able to remove. Sometimes it can be a little bit fiddly. Let's see. Oh, there we go. So that's the old PTFE tube. Next, we're going to have to remove the nozzle, and to do that we need to heat it up to 280 degrees. So because of that, I did have a sock on this, and I definitely recommend these socks. I didn't put one on initially when I had the Mini. I wish I had, because it would have kept the hot end really clean. These are by Thomas Levendig, and I'll put a link to his shop. I'm not sponsored, it's just that this was one of his first prototypes, I think, before he started making them en masse. So I definitely recommend that to keep your hot end clean, and any filament that does solidify on there can just be pulled off nice and easily, and that's lasted for a year. Right, so next I'll heat the hot end up, and then we can try and use the torque wrench and a normal wrench to undo the hot end. So the hot end is now at 280 degrees. I've got the extruder, or rather the hot end, quite near to the main column. So, and note that some torque wrenches, and I don't know whether it includes this one, are not designed to undo, so we'll soon find out. Right, let's try and wiggle this one on. It seems to have got a bit of rubbish on it, so we'll just clean it off a bit. There we go, so that is on there. We have the 16mm wrench to go on the top, apparently, of the hot end, and with luck so I've just unscrewed the sensor from the side, just so that there's more slack on the heater and thermistor wires while we take the hot end out. So I'm just going to carefully undo the nozzle. I don't think it's cooled down. I may need a little go with the socket. Don't know whether I can do that by hand. It's fiddly getting it on. No, I'm going to use a torque wrench on that. The actual heat brake is loose and will just come out finger tight. There we go. That's the old one, and I'm covered in the thermal paste, as you can see there. Sorry if you didn't see all of that. So I'm just going to carefully undo this with a wrench, and we'll just be left with the heater block. So now we just have the heater block. As you can see, it is rather nasty, but that's what happens if you don't put a sock on to begin with. So I'm going to clean this up a little bit, and then we'll start the process of putting the new nozzle on and the new heat break. So I found a piece of card. Let's just move this around a little bit so you can see better. Right, I found a piece of card that is exactly 0.5 millimeter. So if I can tighten up to that point, which I don't think I'm that far off, without causing too much hassle. That's still moving. That's probably, I think, about it, 'cause if I do it too tight, yeah, that's about 0.5 millimeter there. Yeah, I'd say that's 0.5 millimeter, so that's set. So the next part is to put in the new Bondtech heat break. So I've got some of this thermal paste, and I'm going to put it on the heat break. It says to do it not too far towards the end, so mainly in the middle area. So I'm going to smear that on now. I won't do that on camera because I'll probably make a mess, and that won't be a pretty sight. So let's give that a go. Okay, taking the PTFE tube out. Right, that's finger tight, which is probably a lot tighter than the original was. So I'm going to pop this back in. Let's see how that goes. I may just need to undo some of these bolts again, and then I'll push it up further. So the next step is to insert the new Bondtech PTFE tube, and just to make sure that I've actually got the correct one, and we're just going to pop it in just like that. Okay, well, one advantage of you watching me do these videos is you can see where I make mistakes. I wasn't happy with the hot end having such a large gap, so I've just taken it out, put a bit more thermal paste on, pushed it back in, and there was still a substantial gap, which just didn't look right because at the top the PTFE tube just was not sticking out far enough. So I put two fingers under and thumb on the top, pushed pretty hard, and it actually clicked, well, almost clicked into place. It went probably about, I guess, 4 or 5 millimeters further up. So I believe it's probably at the top of the housing now. So I'm now going to repeat the process of putting the PTFE tube in. Let's zoom out again. So I'll put the PTFE tube back in, I'll put the brass fitting back in, back that off a bit, and we'll see how we go from there. One other thing to note, that with the Bondtech, the PTFE tube has a slight chamfer on one end, and that's the end that will go downwards. So just be aware of that. It can actually be quite difficult to see, but there is a very, very slight chamfer. So that end must go in. And unlike with the Prusa instructions, you don't have to leave a full turn on the fitting here. It's not required, so I've just double checked that. So we're just going to pop the fitting on now, make sure that the hot end is pushed up, and loosely tighten the 3 bolts on the side. Hopefully we're near the end. So the brass fittings inserted, I'm just going to pop in the fitting here. There we go, just screw that in by hand, and ideally if you've got a couple of small wrenches, one to hold the bottom and hopefully I've got the right end there, and there we go. And you don't need to do it too tight, that's tight enough I think. So that's all ready. So very close to the end. Now I'm just going to pop these 3 bolts back where they came, give just about enough slack for the cables. Right, the 2 bolts are in there. I've left the middle one open because that's for the sensor, and we're going to adjust that one on the next exercise. Okay, so I've just used a torque wrench. Hopefully I didn't damage the thermistor wire on that. I've just turned it on again so that it can cool itself down. That torque wrench seemed to work quite well. It clicked when it was supposed to, so I guess the proof will be in the pudding when I eventually come to print a test benchy a little bit later on. So I'm just going to let the nozzle cool down, and then we'll do the paper test to set the correct height for the sensor. And just before we do the sensor again, I'm just going to wrap this sheathing back around the cable, pop it in its collar there. Okay, now's the time to test or set the sensor. So I'm just manually moving the long worm screw. You don't want to try and use the actual electronics to be doing this, because you could very easily ram the extruder, or rather the hot end, not the extruder but the hot end, directly into the bed. So we have to do it all the way down like this, and I can pretty much see that the sensor is going to be too low, so I'm just going to, remember that screw is undone, so I can, with a little bit of effort, move it around. Let's try and zoom in a bit. So I've got a piece of paper here, and zoom out, sorry guys. Okay, so you need to fold it 3 times, A4 paper. 1, 2, 3, or if you're in the States then I suppose it would be letter size. Fold it into 3, it's an 80 GSM piece of paper. So your standard typing paper. Pop it underneath, and let's see if we can zoom in a bit more again, and just pop the gantry down. Now nozzle is on the bed, we should be able to get that piece of paper underneath. I think perhaps the sensor might be able to go down. Let me adjust it. Okay, so I've just pushed the sensor down just very slightly, and I can just about put the piece of paper underneath, and it drags a bit when I pull it away. So hopefully that is about the correct setting for it. So let's just move it up a little bit, and I'm going to tighten up that screw. Okay guys, so as far as I can see we've done everything that should be done. I've just put a spool of filament on. I've got a USB stick in the Mini. I've had to add some extra G-codes to cope with the new heat break, and I'll leave a link to those in the description below. so you can see what you have to do. You can either add them into your slicer, like in the Prusa slicer. If you go into the printers tab and look for custom G code, you can just copy and paste the code directly into the appropriate place, and I'll say exactly where that is. Or you can add it onto a USB stick. So the choice is yours. If you add them into the code, every time you generate a print, it will include that code. So in this case, as I'm going to do a calibration now, I'm going to run the codes directly off the USB initially. So let's see how the calibration goes. Right, the calibration's done. It's printed off pretty well. Started off from 0 rather than the old values, and I think hopefully if that's in focus, you can see that's come out really nice indeed. In fact, very, very good. So I'm very pleased with that. I wasn't able to fit the sock on the nozzle yet, so that's going to have to happen after I've done a bit more testing with the benchy, which I'm going to print now, just in case there's any oozing from the nozzle itself. So in case there's any oozing that comes either above the heat block or from below the heat block, I just want to make sure that there's no oozing coming from there once it's been running for a while. If the benchy print's alright, which is a 2-hour print, then I will put the sock on to protect the heat block. So back in a moment, hopefully with the benchy. Now the benchy is completed. There are no leaks around the nozzle or above the heat block, so it looks like everything has worked well. There was no clicking noises at all, so pleased the bench has come out pretty well. So job done. I didn't change the heat break to change the quality, I just wanted to actually stop the clicking. Right, so 24 hours later, I'm printing with the Mini. The print at the moment's been going for about 12 hours. No clicking on the hot end at all, so I'm really pleased with that. So overall, I think a successful change of the heat break and the nozzle. So I hope the instructions were useful. If you'd like to see more of these sort of videos, then please do a like, and a subscribe would always be helpful as well. And I hope to see you next time. Thank you very much.